Today we work with De Morgan's law. So I write down these two formulas, and in some textbooks you can find that you can phrase these two formulas. They refers to the De Morgan's law. I here show you how they works. This sign means that you have a chain of operations for sets from indexed y from 1 to n. A1 or A2 or A3 up to AN. If n equal 2, you have notation for this formula: j equal 1 up to 2, aj, and you have just two operations, just two sets here. You can switch j for 1, a1, or and switch j to 2 here, a1 or a2. If you have 3, and you have 3a, a1, a2, and a3, and chain operation of all logic join operation. And the same thing about this one formula. What about this line? For set operation, it used like negation of this set. Negation A. For example, if we have a space set S as it is a space as it is a space, it is a set of all sets. So it's a set which includes all sets. So if it is A, negation of A, all of these, the rest part of S as a space set, is a negation. Negation of A. Okay. So what does it mean, De Morgan's law? Negation of the set of all operations gives set of and operations between negation of A. And now we try to explain it. How does it work? For example, n equal 1. So this formula, j equal 1 up to n, ag, it gives result a1 negation over a2. And according this operation according this formula, according to Morgan's law, it is a1 negation of a1 and negation of a2. Okay, let's use the Venn diagram. So we have to make visualization on the left side and visualization on the right side. Let's do it. It is A1. It is A2. Okay. Now we have made this operation, and it gives us this one. I use especially W in all of these things. But we have a negation of this operation, so we get to this part. So this negation of this blue shape is all space beyond this blue space. So it gives us these. I use specially like shaded area. I can make here shaded area. So this shaded area gives you A1 or A2. Okay, what about the right side? The right side, I can use the same green ink. A1 negation, it is A1. Negation of A1, I use specially this everything which is beyond the A1. Okay. A2 is still the same A2 as for previous one situation. This one A2. And negation of A2 is everything which is beyond the A2 space. One more again, I use the blue ink here. Everything which is beyond A2 is this one negation. And what about an operation for blue shaded area and for black shaded area? I use specially which belongs how to say it, simultaneously to blue shaded area and to black shaded area. I use these green in here, and what's the area here? Beyond the red part and beyond the. So we can have here. Then blue part and this one, blue dash, they coincide these red ones. Look here, the are this one area, they just shaded by black dash, this one by just blue. So we can have this one and exclude both of them, and we have the same area as we had of the previous one thing. So here we have A1, A2. Yes, I used the wrong ink, and that's why I made a green cloud here. This form, and we can notice that this green part here coincide this black part at the left part of this diagram. It means that this one thing equal, I use double equal side to the A2, A1 and A2. Okay, so for example, we can add one extra set here. And we can use A1, A1 or A2 or A3 negation equal A1 and A2 and A3, but negation of this set. We can use the same one approach. So we have here three sets, A1, A2, A3, and negation of them is stretching beyond this red area, this green one. What about this one, the right side? We have A1, A2, A3, A1, A2, A3, but previously we have to consider the negation of each of them. I use green one. It is negation of A1, negation of A2. The whole area beyond A2, and negation of A3 I use these black ink. It's beyond A3 area. And now I have to intersect green, black and blue areas. So I have to pick out the areas which can consist of all of these dashes inked by different colors. And I have what I have. Only part beyond all of these three shapes, because only the space which simultaneously beyond each of them consists of black, blue and green inks, and it means that I use specially A1, A2, A3 negation equal each one colored part. I use blue, okay, if you don't mind. A1, A2 and A3 part. Okay. So if you expand and this formula step by step and consider the chain of the all operation on the left side and operation on the right side, and you can have the chain of this operation, you can get to these equalities for the common situation when we have n here, not 2, 1 or 3, but for any n they have the same result. So we can say that we kind of proved the De Morgan's law. Okay, thank you very much, bye bye.